In this video, I will show you how to find the inverse of a 2 by 2 matrix. Basically, there are two steps to it. Step 1 is that you find the determinant of the matrix. And step 2 is you use this formula that involves the reciprocal of the determinant and using this little pattern. So, if matrix A is ABCD, then the inverse matrix, inverse of A, is going to be the reciprocal of the determinant. And now, what's going on here, I like to use this phrase, reverse, negate. Back in the day, there was a line dance song where part of the instructions would go, reverse, reverse, and everyone would spin around, reverse, reverse. So that always pops into my head when I'm doing this because I always say reverse, negate, reverse, negate. And what I mean by that is I'm talking about the diagonals, and I've color coordinated them here. Can't talk today. When I say reverse, notice how the diagonal AD became DA. Alright, so this diagonal switched places, they reversed. And then the blue diagonal, I'm saying negate. See the C and the B, they didn't move, I just changed the sign. So reverse the down diagonal, negate the up diagonal. Reverse, negate. Oh, one more detail. The determinant obviously can't be 0. The first thing we do is we do the reciprocal of the determinant. And if the determinant were 0, I'd have 1 over 0. You can't divide by 0. That's crazy. Okay, so this will make more sense as we do a problem. So if I want to find the inverse of this matrix, the first thing I need to do, step 1, is to find the determinant. Okay, so that's what I have to do first. Find the determinant. And let's call this matrix A. So I'm just going to say find determinant of A. The way we do the determinant of a 2 by 2 matrix is the down diagonal minus the up diagonal. So the down diagonal is 1/2 times 1/4. Okay, minus the up diagonal, which is 0 times 1. So the down diagonal is 1/8 minus the up diagonal, which is 0. So the determinant is 1/8. So hang on to that. Put that in your back pocket. The determinant is 1/8. And we've now done step 1. We found the determinant and it's not 0. So far so good. So now, if I want to do the inverse of A, I'm going to now do the reciprocal of the determinant, and then I'm going to reverse, negate the down diagonal and the up diagonal. So I think I'll change colors because I'm in inverse now. I'm going into the upside down. So A inverse, I'm going to do the reciprocal of the determinant. So since the determinant was 1/8, the reciprocal will be 8. Alright? Now, this is not the determinant. This is just going to be a matrix. So I need to reverse, negate. I'm going to reverse the down diagonal and negate the up diagonal. So you know what? This might need to be a little bit bigger. Just a little bit bigger, my friends. So if I reverse the down diagonal, that means that the 1/4 is going to go here, and the 1/2 is going to go here. Okay, that's the reverse part. Now here comes the negate part. These don't move, but I just changed the sign. Well, the opposite of 0 is still 0. That doesn't change. But the opposite of 1 is -1. So reverse, negate. I reversed the down diagonal and I negated the up diagonal. So all that's left is to multiply all these by the scalar of 8. So A inverse should equal, let's see, 8 times 1/4, that's 2. because 4 goes into 8 twice. 8 times 0, of course, is 0. 8 times negative 1 is negative 8. And 8 times a half is 4. Half of 8 is 4. So this, my friends, is a inverse. Alright, this is the final answer. Let's do a couple more examples. So again, you know what, let's call this matrix B this time. So I want to find the inverse of matrix B. But finding the inverse has two steps. First you find the determinant, then the inverse will be the reciprocal of the determinant times the reverse negate matrix. Okay, so step 1 is to find the determinant of matrix B. So let's do that. Let's find the determinant of B. Well, the way you find the determinant of a 2 by 2 matrix is the down diagonal minus the up diagonal. So the down diagonal is 12 minus the up diagonal, which is 12. Again, 12 minus 12, that's 0. The determinant is 0. That means that B inverse does not exist. If the determinant is 0, the inverse does not exist. Alright, that's it for number 17. Let's try number 18. Okay, let's call this matrix C. So, step 1, find the determinant. Step 2, the inverse will be the reciprocal times the reverse negate matrix. So step 1 is to find the determinant of matrix C. So that's going to be the down diagonal minus the up diagonal. The down diagonal, I better break this down. So the down diagonal, meaning 1/2 times 13, minus the up diagonal, which is 1/10 times 5. 1/2 times 13, 1/10 times 5. Okay, down diagonal minus up diagonal. So this is like having 13 over 1 and 5 over 1. Multiplying straight across, I've got now 13 over 2 minus, and this is going to be 5 over 10, which reduces down to 1/2. Right? 5 over 10, that's 1/2. So that's nice because the denominators are the same. So 13 halves minus 1/2 is going to be 12 halves, which conveniently is 6. So the determinant of matrix C is 6. Okay, remember that, please. The determinant of C is 6. Since it's not 0, we can move on to step 2. Alright, step 2 says that C inverse is going to equal the reciprocal of the determinant. So it's going to be 1/6 times the reverse negate matrix. Okay, I'm going to reverse negate. I'm going to reverse the down diagonal and negate the up diagonal. So when I say reverse, I'm talking about switching the down diagonal. So the 13 will go here and the 1/2 will go here. That's the reverse part. The negate part means these stay where they are, but the signs change. So this will be -5 and this will be -1/10. Reverse negate. That's what I mean when I say that craziness. So all I have to do is multiply all of these elements by the scalar of 1/6, and that will be my answer. So let's see, I'm running out of space. So C inverse is going to equal 1/6 times 13 is 13/6. 1/6 times -10 is going to be negative, did I say -10? I meant -1/10 is going to be -1/60th. Okay, 1/6 times -5 is going to be -5/6, and 1/6 times 1/2 is going to be 1/12. So this should be the inverse of matrix C. Alright, these are so easy. Let's do a couple more. Let's call this matrix D. I want to find D inverse. So there are two steps. Step 1 is to find the determinant of matrix D. The determinant is the down diagonal minus the up diagonal. The down diagonal is -4. The up diagonal is -6, so I'm going to put +6 because minus a negative is addition. So put these together, I'm going to get 2. So the determinant of matrix D is 2. Alright, thus endeth step 1. Now step 2. Switching colors for step 2. For step 2, if I want to find D inverse, I'm going to do the reciprocal of the determinant. So that's going to be 1/2. And then I'm going to do the reverse negate matrix. Reverse the down diagonal. So that's going to be -2, +2. Negate the up diagonal. So these are going to stay where they are, but this will become -1, and the -6 will become +6. So I reverse the down diagonal and negate the up diagonal. Reverse, negate. So that's it. So all I have to do is multiply by the scalar, and I'm done. So D inverse should equal 1/2 times -2 is -1. 1/2 times 6 is 3. 1/2 times -1 is -1/2. 1/2 times 2 is 1. That's it. This is D inverse. Alright, just when I thought I was on a roll, they throw pi in here. I'm just going to assume that whoever created this worksheet wants us to use a decimal. I don't see any way around having a decimal. So that's what I'm going to do. I'm going to round to 2 decimal places. So this is matrix E. I'm just making that up. Let's call this matrix E. So step 1 is to find the determinant of matrix E. That's the down diagonal minus the up diagonal. So that's going to be 5 pi minus 2. Okay, again, I'm just going to go ahead and turn this into a decimal. Alright, I got 13.71, rounding to the nearest hundredth. So now it is time to do the second step, where E inverse is going to be the reciprocal of the determinant. So it's like we're going to do 1 over 13.71 times the reverse negate matrix. Okay, when I say reverse negate, I'm talking about reversing the down diagonal, so it'll become 5 here and pi here, and negating the up diagonal. So this would be -1 and -2. They don't move, we just change the signs. Okay, that's what I mean when I say reverse negate. So now I need to basically divide each one of these by 13.71. That's what this reciprocal business really is. Doing the reciprocal is a way to express that we are dividing by the determinant. So I'm really doing 5 divided by 13.71, -2 divided by 13.71, -1 divided by 13.71, and pi divided by 13.71. So if we do that, using a calculator, obviously, then I will do that off camera and show you what we get. And this is what I get when I divide each one of these 4 numbers by 13.71. So I don't see any way around getting decimals, so there you go. And we are down to the last problem. Again, let's see, let's call this matrix F. If we want to find the inverse of this matrix, it's two steps we have to do. First, we need to find the determinant of matrix F. That's the down diagonal minus the up diagonal. So that's going to be -6 minus 30. So that's going to be -36. So that's the determinant of F. File that away for future reference. Okay, that's the end of step 1. For step 2, I can find F inverse by doing the reciprocal of the determinant. So I'm going to have -1 over 36, or 1 over -36, whichever way you want to look at it. And I'm going to multiply that by the reverse negate matrix. Okay, reverse negate. What am I talking about? Reverse negate. The down diagonal we reverse. That means we put the -2 here and the 3 here. The up diagonal we negate. That means we're going to put the -5 here and -6 here. We didn't move those, we just changed the signs. If these had been negative, we would have made them positive. Okay, so that's it. So that means to find F inverse, I just need to multiply each of these elements by the scalar -1/36. So what's going to happen here? So this will be positive 2 over 36. So that's going to be 1/18. Let's see. This will be positive 1/6 when I do -1/36 times -6. Because look, -1/36 times -6. This is like -6 over 1. You multiply straight across. That's why it'll be 6 over 36, which reduces down to 1/6. Okay, this is going to give me a positive 5 over 36. That doesn't reduce. But this does. I'm going to have -1/12 when I do that, because 3 over 36 is what I get, alright, because that's like 3 over 1, right? And that reduces down to 1/12. And it's negative because of that. That is it, folks. That is F inverse. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.